What's up guys, in today's video I will give simple tricks to calculate isomers. In last video I gave tricks to calculate number of isomers of alcohol and ether. So in today's video I will teach you to calculate number of isomers of first of all aldehyde and ketone, and secondly first degree, second degree and third degree amines from their general formula. So in last video there is a simple rule: number of carbon atom, isomers, number of isomers 1 2 3 4 5 and isomers 1 1 2 4 8. So you can remember this rule by 11,248 1 1 2 4 8. This is very important. Now I will teach you how to calculate number of isomers of aldehyde and ketone. Aldehyde and ketone. So question number 1. So find the number of isomers of C3H6O. You have to recognize this is aldehyde or ketone or alcohol or ether. Aldehyde and ketone have general formula CnH2nO. So this belongs to this molecular formula. C3 double of 3 is 6 and O. So this C3H6O belongs to CnH2nO. But alcohol and ether has a general formula CnH2n plus 2O. So you can recognize alcohol and ether and aldehyde and ketone by general formula. Both has different general formula. So let's calculate the number of isomers of C3H6O. So to calculate this, first of all you have to write the aldehyde structure CCCHO. So here are 3 carbon atoms which are C3H6O. So number of carbon atoms equal 3. So isomers equal. So in previous video there is simple rule 11,248. So for 3 carbon atoms 1 2 3 carbon atom, 2 isomers are present. So for aldehyde structure isomers is 2, and for ketonic structure we should write ketone structure. So 1 C double bond O and C 1 2 3 carbon, and you can put rest hydrogen. So number of carbon atoms equal. You should look only one chain beside this functional group. Here are 2 chains beyond left and in the right. So both has similar alkyl group C and C carbon atom. So only one carbon is present. So isomers equal. For number of carbon atom 1 isomer is present. So total isomers equal 3 plus 1 equal 4. So for general formula C3H6O, total isomers equal 4. So let's take another example. Question number 2. Let's take another example C5H10O. So to calculate the number of isomer, first of all write down aldehyde structure. For aldehyde 1 2 3 4 and CHO. So number of carbon atom equal 1 2 3 4 and isomers equal @11248. So for 4 carbon atom 1 2 3 4 4 isomers are present. So second, write down ketone structure 1 2 3 4 5. So number of carbon atom equal, look only one side of functional group, both sides are same, so 2 carbon atom 1 2 carbon atom. So isomers equal 2 carbon atom are present, so 1 2 1 isomer. And another structure of ketone can also be drawn. So 1 2 3 4 5. Here 3 carbon are present, so isomers equal 3 carbon are present, so 1 2 3, so 2 isomers are formed. So total isomers equal 4 plus 1 plus 2 equal 7. So for C5H10O total 7 isomers are present. Aldehyde isomers are 4 and ketone isomers are 3. Aldehyde isomers are 4 and these both are ketone structures, so ketone isomers are 2 plus 1 3. So to calculate the number of isomers for aldehyde and ketone we have already studied. So let's start for amine. First degree amine, second degree amine and third degree amine. So we have to know the nomenclature of first degree amine, second degree amine and third degree amine, as this is very important. So let's start with nomenclature. First of all, CH3, CH2, CH2 and H2. If this form is present, then it is primary form or first degree form. So the nomenclature of this compound is 1 2 1 1 2 3, means propane and 1 amine, or 1 propanamine. Both nomenclature are correct. So CH3 CH and H2 CH3. This form is also primary form, first degree form. As this functional group is present in the second position, so many students will confuse that it is secondary form, but it is also primary form as NH2 form is present. So nomenclature is propane 2 amine. So another form CH3 and H, CH2 CH2 CH3. As NH form is present, so it is secondary form, 2 degree form, second degree form or 2 degree form, as NH is present. If NH2 is present, it is primary form. If NH is present, it is secondary form. So nomenclature is, this is propane group, propane, and this is methyl group, methyl group. So N methyl, smaller group, and then larger group, larger group, propane, 1 amine. So this is the nomenclature of this secondary form. And let's take another example of secondary form. C2H5 NH, C2H5. As NH form is present, this is also secondary form or 2-degree form. So nomenclature is, and both forms are same. So N ethyl, smaller group, and then larger group, ethanamine, ethanamine. So this is nomenclature of primary amine, this secondary amine, this is also secondary amine. So let's start calculating isomers for C4H11N. First of all, we have to know primary form, secondary form, and tertiary form. And first of all, writing structure of primary form, C4 and H2. This is primary form as NH2 group is present. So number of carbon atom equal 4. So isomers equal, we have to remember 1, 1, 2, 4, 8. So for carbon number 4, 4 isomers are present. 1, 2, 3, 4 carbon atom, 4 isomers are present. This is primary form. Now let's start for secondary form, CS3. As C4H11N molecular formula is given. So CS3N H CS2 CS2 CS3, 1, 2, 3, 4 carbon atom, and 3, 5, 7, 10, 11. So this is the structural formula of this molecular formula. So here number of carbon atom equal, we have to remember 1, 1, 2, 4, 8. 1, 1, 2, 4, 8. So for this structural formula, this is the secondary form, and number of carbon atom equal to, we have to choose the longer chain, and as this is the longer chain, number of carbon atom equal 3. So isomers equal 1 carbon atom, 2, 3 carbon atom, 2 isomers. And as tertiary form is also present in this formula. So CS3 and CS3 and C2H5, 2, 3, 4 carbon atom. So number of carbon atom look longer chain, so number of carbon atom equal 2, and isomers equal, for 2 carbon atom 1, 2, so 1 isomer. So total isomer of this molecular formula equal here we have calculate for primary 4 O plus 2 plus 1 7. So 7 isomers are present. So let's take another example. C3H9N. So calculate total number of isomers for this molecular formula. So for primary structure C3 and H2. So number of carbon atom equal 3. So we have to remember this formula. For 3 carbon atom, 2 isomers are present. So isomers equal 2. So for now second degree structure NCH3 C2H5 and H. This is second degree structure. For this, number of carbon atom equal 2. Take longer chain 2. So isomers equal, for we have to remember 1 1 2 4 8. So for carbon number 2, 1 isomer is present. Now third degree structure CH3 and CH3 and CH3. So 3 carbon atom and 9 hydrogen, 1 nitrogen. So number of carbon atoms equal 1. Take only one chain. So isomers equal, for 1 carbon atom 1 isomers. So total isomers equal 2 plus 1 plus 1. So 2 3 4 isomers are present. So for general formula C3H9N, 4 isomers are present. So for nomenclature of 3 degree amines, I have taught first degree and second degree amines nomenclature just before. Now 3 degree amine nomenclature. So let's take one example. C2H5N CH3 CH2 CH2 CH3. So the rule is first smaller chain and then longer chain. This is the longest chain and these two are the smallest chain. For this is methyl group, this is ethyl, and this is propane group. So for 2 smaller groups we have to look the alphabetical order. First E comes first. So priority goes to ethyl. So N ethyl, N methyl, propane 1 2 3. This is numbering of carbon atoms. So propane 1 amine. This is the correct nomenclature. So let's take another example. C2H5 and C2H5. and C2H5. So all groups are same. So this is very easy. N diethyl ethane amine. So let's take another example also. CS3 CS2 CH CH3 N. CS3 CS2 sorry CS2 CS3 and another group CS3. So let's find out longer chain. This is the longest chain. 1 2 3 4. So this is butyl group, and this is the smallest, and this is methyl, and this is also smaller. So this is ethyl group. So first priority goes to E because first alphabetical order. N ethyl and methyl numbering goes like this: 1 2 3 4, because your functional group is in the second position, and while doing numbering from this side, third position. So priority goes to second position, smallest position. So second position. So N methyl butane 2 amine, and this is the correct nomenclature for third degree amine. So hope you like this video. So please don't forget to subscribe my channel so that I will give you more videos relating to entrance examination. So don't forget to subscribe my channel. Thank you.